Yesterday we played around with different polygons, regular polygons, and we were looking at whether or not they tessellate. We also looked at walking around a shape, and we determined when we walked around a shape it was 360 degrees, whether it's a triangle, a square, a hexagon. And one of the things that we determined when walking around a shape is that we can find an exterior angle measure and then interior angle measure. So the exterior angle can be found by taking 360 degrees, because that's all the way around the shape, and dividing it by the number of sides. The interior and exterior angles form a straight line, so they total 180 degrees. So once you find the exterior angle, then you can find the interior angle. So the interior angle is 180 minus the exterior angle. And these are formulas that we're going to be using to find the different measures. So the first problem, example 1, asks you to find the measure of an interior angle. So we have a regular polygon with 40 sides. The interior angle is the second thing that we can find after we find the exterior angle. So we have 360 divided by the number of sides, which is 40. And that gives us 9 degrees. The next step then is to find the interior angle. So we take 180 and subtract 9, because that's our exterior angle, and it gives us 171 degrees. And this is our final answer. Part B asks us to find the sum of the measures of the interior angles. One interior angle has a measure of 171. We have 40 sides, so that means we have 40 interior angles. So 171 times 40 gives us 6,840 degrees. We found this by taking the interior angle and multiplying it by the number of sides. Another important little formula to have. Example 2, find the measure of an interior angle with a regular polygon of 105 sides. So we're being asked to find the interior angle, and it has 105 sides. We need to use this formula, but we need to find the exterior angle first. So we have 360 degrees divided by 105. So 360 divided by 105 gives you 3.42 degrees. So we have the exterior angle measure. Now we need to find the interior angle measure. So we have 180 minus 3.42. And that gives us 176.58 degrees. Example 3, what is the biggest polygon that will tessellate the plane? When we looked at all the shapes that would tessellate yesterday, you should have seen that the hexagon is the largest polygon that will tessellate the plane. Example 4. A box manufacturer wishes to cut templates from a roll of cardboard 200 centimeters wide and 5,000 centimeters long. The dimensions of the smallest rectangle that will enclose the template are 11.2 by 15.4 centimeters. How many templates can be cut from one roll? So, if you look at the pictures, we have 5,000 by 200. We're laying the templates out two different ways to determine which way we can lay them to get the most templates cut out. So, we have this first design is 5,000 this way and 200 this way. We have smaller templates that are 15.4 long this way and they're 11.2 wide this way. So what we want to look at is how many times 15.4 will go into 5,000 and how many times 11.2 will go into 200. And then look at the total number of templates that we can get cut out. Now, we don't want to have partial templates, we want to see how many whole templates we can cut. So, design number 1. We take the length of the rectangle and divide it by the length of the template, which is 15.4. And we want to take the width of the template, of the rectangle, and divide it by the width of the template. So 5,000 divided by 15.4 gives us 324.67. But we don't want partial templates. We want whole templates. So we can get 324 whole templates out. So now we want to see how many we can cut from the width. So 200 divided by 11.2 gives us 17.85. But again, we don't want partial templates, we want whole templates, and we can cut 17 whole templates out. We don't want the partial. So the length by the width, multiply them to find out the total number of templates we can cut. Laying it out this way, 324 times 17 will give us 5,508 templates. So let's see if we can get more cut out on the second design. So design number 2. It's still 5,000 long this way and 200 wide this way. But we've flipped them perpendicularly. So it's 15.4 long this way and 11.2 across the width this way. So this time we have to see how many times 11.2 goes into 5,000 and how many times 15.4 goes into 200. So we take the 5,000 and divide it by 11.2. So 5,000 divided by 11.2 gives us 446.42. We only want the whole templates, so we'll drop the partial ones. And now we need to check the width. We take 200 and divide it by 15.4. We get 12.98. We don't want the partials, we only want the wholes. And then we need to multiply the length by the width to see how many total templates we can get. So 446 times 12 gives us 5,352 templates. you always need to try both ways, because one way is going to give you more templates than the other. So this is the maximum number of templates that can be cut from one roll if we lay it out this design. So design number 1 is going to give us the most templates, which is 5,508. Now what you need to work on for the remainder of the hour is an assignment from your textbook, 2.1, 2.2, 2.3, 2.5, and 2.6. It is due at the beginning of class tomorrow.